Hello everyone. In this section we'll be talking about factoring quadratic expressions. And let's just make sure we really understand this word factoring. Sometimes it gets used without people really embracing what it means. To factor something means to write it in terms of things multiplied together, typically simpler things multiplied together. So as an example, if I take the number 30, 30 is 2 times 3 times 5. I can express the number 30 in terms of 3 simpler numbers multiplied together. This also works from an algebraic point of view. I could say that 5x squared is 5 times x times x. I am expressing 5x squared as simpler things multiplied together. Or, if we remember foiling, 2x plus 1 times x minus 5. If I FOIL that out, that's 2x squared minus 10x plus x minus 5, which simplifies to 2x squared minus 9x minus 5. So what we could say, now that we know this, is, oh, if I have 2x squared minus 9x minus 5, which is pretty complicated, that's actually the same as the simpler expression 2x plus 1 times the simpler expression x minus 5. And what we want to understand here is that for many quadratic trinomials, for things of this form, there's an x squared and there's an x and there's a constant, we can write them as something simpler with just 2 terms and an x times something else simpler, 2 terms and an x. Binomials, linear binomials. Certainly not everything factors, but many things factor, and we want to get good at that. Here we knew this because I had already done that. We want to be able to look at something and figure out, how could I come up with the things that multiply together to give it to us? So here is the easiest type, and luckily the easiest type is also the type you will encounter the most often. It's a quadratic where the leading coefficient is 1. So it starts with just plain x squared, not 2x squared, not 7x squared. It starts with plain old x squared. So what we do there is we focus on the other numbers. We focus on this number b and this number c. And we ask ourselves, can I come up with 2 numbers where when I add them together, my answer is b, the thing in front of x. And when I multiply them together, my answer is c. And I use those to fill in a factorization. So let's look at an example here. X squared plus 9x plus 20. It begins with plain old x squared, so this technique will work. I am asking myself, can I come up with 2 numbers where when I add them together, I get 9. And when I multiply them together, I get 20. And hopefully you came up with 4 and 5. What that means is that this expression factors as x plus 4 times x plus 5. And we can check that by foiling. If I FOIL that out, I get x squared plus 5x plus 4x plus 20. The middle 2 terms give me 9x, and this is correct. This will work when your thing starts with x squared. And if it starts with negative x squared, the trick is just factor out a negative from everything. In the short term, something to have in mind is if you're asked to factor something, it does factor. Not everything will factor successfully, but in this section, we're mostly practicing using factoring techniques on things where they apply. Later on, we'll worry more about what does factor or what doesn't factor. But using this trick, try these 2 examples. Hit pause and actually try them. So hopefully you did that. For the first one here, right, we want to look at this. And what makes this a little bit challenging is there is a negative. Don't say c is 72. C is negative 72. So we want to come up with 2 numbers where when we add them together, we get 14. And when we multiply them together, we get negative 72. And if I multiply two numbers to get a negative, that means one of them is positive and one of them is negative. So I can experiment with different possibilities. Certainly, I can think about ways to factor 72 and then just remember, it's 2 times 36. It's 1 times 72. Let's just get that clean. It's 4 times 18. It's 9 times 8. It's 6 times 12. It's 3 times 24, right? This first example is actually a little challenging because there are many different ways. And then if we want to get negative 72, basically we take one of these numbers and make it negative. So after experimenting a little bit, hopefully you realize that the numbers that would work would be positive 18 and negative 4. So the factorization here is we would have x plus 18, x minus 4. For this second example, I strongly recommend you look at that negative and you just say, I do not like doing this with a negative in front. So let me factor out a negative from everything. Let me just say this is like the number negative 1 times the opposite of everything else. This is factoring out a negative. If you want to, you can write this as the number negative 1. Number negative 1 times everything else. And then let's factor what's left. It starts with plain old x squared, so we can use that rule. I want to think of two numbers where when I add them together, I get negative 13. When I multiply them, I get 12. And again, you might want to think about positive versus negative. The only way I can have two numbers where multiplication is positive and addition is negative is if they're both negative. And hopefully you realize that the numbers that work are negative 1 and negative 12. So we have this is negative 1 times x minus 1 times x minus 12. That is our complete factorization. Just treat the negative as its own factor. So those are the easiest factoring problems. Another example that's not particularly hard is when you pull out a common factor. This is very useful if you only have 2 terms, but it works with 3 terms. And this is actually something you want to look for first. I want to factor this. It only has 2 terms. So I could ask myself, is there something they have in common? I might notice they both have n in them, and they're both divisible by 3. So I could just pull out a common factor. They're both divisible by 3n. And then what's left? Well, if I divide this by 3n, I'm left with the number 2 and one more copy of n. If I divide the second part by 3n, I'm just left with the number 3. That's our factorization. Always look to do this first, right? So we'll make a note here. Check for a common factor first. It can turn a hard problem into an easier problem. So with that in mind, pause to try this next one. Hopefully we noticed that everything we're looking at is divisible by 4. So if we pull that out at the very beginning, it's easier because now we get to think about the factoring with smaller numbers. So I want to think of 2 numbers where when I add them together, I get positive 5. But when I multiply them together, I get negative 14. And hopefully you hit upon the combination of 7 and negative 2. Okay, now we get to the hard part. The hard part is when a is not 1 or negative 1. So if I had something like 2x squared plus 3x minus 5. I can't do quite the same factoring. Sorry for the pause there. Someone walked into the room where I was doing this. I can't do this quite the same way. It is more complicated when it starts with something like 2x squared instead of x squared. We can try to just do this by guess and check. So what you could do certainly is you could say, all right, well, I'm going to factor this. If I started with 2x squared, I know that what goes here and what goes here multiplied together to give me 2x squared. And there's really only one way of getting that. It's 2x times x. And I might notice that I ended with negative 5. So whatever I multiplied at the end gives me negative 5. You're kind of focusing on the f in FOIL and the L in FOIL. The middle term is more complicated. So what you could do, this is certainly a valid option. You know that these multiply to give negative 5. So certainly what you could do is just elaborate guess and check where you look at all of the different combinations. And negative 5 isn't that bad. Maybe it's 1 and negative 5. Maybe it's 5 and negative 1. Maybe it's negative 1 and 5. Maybe it's negative 5 and 1. We could just try all of those different combinations. Hey, what happens if I take 2x plus 1 times x minus 5? And you could FOIL that out and see if you get this thing. You won't. You could try the next combination. 2x plus 5 times x minus 1. If we FOIL that out, we get 2x squared minus 2x plus 5x minus 5, which does work. So here we got pretty lucky in that the second thing we tried works. You are absolutely allowed to do this. And hopefully you figure it out on your first or second or third or fourth try. It's not the end of the world to spend a couple of minutes on this. But I will tell you, guess and check, sometimes you hit a wall. Sometimes it feels like there are too many combinations or you can't remember which ones you've tried and which ones you haven't tried. So here is another technique. I'm not going to force you to do this, right? You can use the guess and check technique. But here's something a little more systematic. If you really want to follow rules and get to an answer, eventually you can do this. It's not fast, but it is reliable. So what we're going to do is we're going to look at A times C. What happens when we multiply the first coefficient by the constant? So we're going to do the same thing as we did before in terms of think about a product, think about a sum. We want to come up with two numbers whose product is A times C and whose sum is B. Then we will use those to break up the middle term, and we'll use a technique called factoring by grouping. That basically means 2 at a time. Let me show you an example. So for this example, we have 2x squared plus 11x plus 12. So I'm going to look at 2 times 12. This first coefficient times C. That's 24. And then B is just 11. So I am asking myself, can I come up with two numbers where when I multiply them together, I get 24, and when I add them together, I get 11? Right? This is the same kind of question we've asked before. And hopefully you realize that 3 and 8 will work. Now we're not done. This just gets us started. We will use these numbers 3 and 8 to break up 11x. So I'm going to write 11x as 3x plus 8x. So rewriting the whole thing, I have 2x squared plus 3x plus 8x plus 12. Then I will proceed by using a technique called factoring by grouping. I have 4 terms. Let's just look at them 2 at a time. Number 1 and number 2, number 3 and number 4. Pull out any common factor. From the first 2, the only thing they have in common is x. So I will write an x, and what's left after I factor out an x is 2x plus 3. Now I'll look at terms 3 and 4. What they have in common is the number 4. So I will factor out a 4, and what's left is 2x plus 3, which is the same thing. If this technique works, you will get the same thing. So what we actually have here is x copies of this pink thing plus 4 copies of this pink thing. What that really means is we have x plus 4 times 2x plus 3. That is the correct factoring, and you could check by foiling. So with that technique in mind, try this one. 4x squared minus 4x minus 3. So my hope is you did that. If you wanted to do guess and check, you can. Here, guess and check is a little harder than that first example because 4x squared, we might have gotten that by x times 4x. We might have gotten that by 2x times 2x. There's too many things to check. So I'm going to do this trick from before. First and last multiplied together, a times c is negative 12. B is negative 4. So I'm trying to think of 2 numbers where when I multiply them together, I get negative 12. When I add them together, I get negative 4. And the numbers that work are negative 6 and 2. So I can write this as 4x squared minus 6x, sorry, that's a positive 2, plus 2x minus 3. Now factor them 2 at a time. 4x squared and 6x have 2x in common, leaving 2x minus 3. Here, 2x and negative 3 don't have anything in common. If they don't have anything in common, just so that we can reflect this pattern, pretend you're factoring out the number 1. We have 1 copy of 2x minus 3, so I'm writing it that way, because that will allow us to notice this pattern. Oh, I have something here times 2x minus 3, plus something here times 2x minus 3. So the overall factorization is 2x plus 1 times 2x minus 3. And if I want to check by foiling, sometimes there's an explicit instruction to check by foiling, but it's always a good idea if you have the time. These problems are always checkable. If you're not sure you factored correctly, multiply it out. If we FOIL this, we get 4x squared minus 6x plus 2x minus 3, which checks out. Okay. These problems, they're not easy, right? You need to either do guess and check, which requires a lot of combinations, or multiple steps. I would never assign this thinking you can do it in a minute. Easier factoring problems you can probably do in 15 seconds. This one, probably 2 minutes, 3 minutes to do it carefully and comfortably and mechanically without stress, right? They are not immediate, but they're certainly doable. Couple things to notice in terms of patterns. So if I have a plus b quantity squared, right, let's just note that this is not the same as a squared plus b squared. This is one of the most common errors, but it's still not true. This means a plus b times a plus b. And if I FOIL that out, that's a squared plus ab plus ba plus b squared. And we'll notice those 2 middle terms are actually the same thing. Over here, if we FOIL it out, we have a squared minus ab plus ba minus b squared. And in this case, we notice the middle terms cancel. These are patterns worth remembering, especially if we're going backwards. So just patterns to notice is that a squared plus 2ab plus b squared is actually the result of just taking a plus b and squaring it. If you see a version with a negative middle term, it means we had a negative over here. And if you see perfect square minus perfect square, that's the result of multiplying together what's called a conjugate pair. One version is a plus b, the other version is a minus b. These patterns can be really helpful if you notice you're factoring something that begins and ends with perfect squares. If you notice that at the beginning it's the result of squaring something and at the end it's the result of squaring something, ask yourself if it's following one of these patterns. So with that in mind, try these two. Okay, I hope you hit pause to do that. So here, what we might notice is, oh, this is starting with a perfect square. It's like a equals 2x, and I'm starting with the result of squaring 2x times 2x. I want to be on the lookout for perfect squares. And if b is equal to 3, that's what I have here. So this begins with a perfect square and ends with a perfect square. Maybe it's following one of these patterns. Let's ask ourselves about this middle term. Is the middle term 2ab? Well, if this is a and b, then 2ab would be 2 times 2x times 3, which is 12x, and that's what we have here, just a negative version. So this is following that pattern. If we notice this is a pattern, we just plain know that this is 2x minus 3 quantity squared. You can factor it using the other techniques. That's certainly not terrible, but you will save yourself a little bit of time if you notice that pattern. Again, we have a pattern. If a is 4y, we're noticing this is the result of squaring that. 4 times 4 is 16, y times y is y squared. If b is 5, we're noticing that's 5 times 5. This is what's called a difference of perfect squares. Difference is when we subtract. This rule only works when we are subtracting perfect squares. If we're adding, we're out of luck. So what we notice is, oh, this is just something squared minus something squared. I know as a shortcut that this will just be 4y plus 5 times 4y minus 5. It is much, much easier to notice that pattern than it is to try to factor it any other way. All right, there was a lot in this section. You want to practice, practice, practice. Factoring does not go away for the next several years of math. The better you are at factoring, the easier it will be to solve problems because so many of them involve factoring as a step in a longer problem. But that is it for what I need to show you in this section.